This is question number 4 on the June 2013 AQA Statistics 1 paper. So we've got a question here. We've got girth, length and weight of pigs, a sample of 20 pigs. So straight away I can write down n equals 20. N equals 20. So we've got some summary data here, and I need to calculate the value of the product moment correlation coefficient between girth and weight, and then length and weight. So I'm going to use my formula book, and I've got the product moment correlation coefficient is. So we're just looking at the first bit of it there, because these are the summary data that we've got. So I need to do s of xy divided by the square root of sxx times s of yy. So in our case, girth, we've got girth g meters. And to start with, we're looking at weight. So weight is y kilograms. So for part AI, I need to use sxy. So that would be gy, sgy, divided by the square root of sgg times syy. So that's just going to be 24.15 divided by the square root of sgg, which is 0.1196, multiplied by syy, which is 5880. Okay, so I'm going to do that on my calculator over here. Plug that in, 24.15 divided by square root of 0.1196 times 5880. 0.9106, and it doesn't tell us how many significant figures or decimal places it wants us to give our solution. So if you go back to the instructions on the front of the paper, it tells us the final answer should normally be given to 3 significant figures. So I'm just going to round that to 0.911. Part 2, very similar. So this time now I'm doing length and weight. So length is L, so I need S of Ly over the square root of SLL times by SYY. So that's 10.25 divided by square root of SLL, which is 0.0436, and then SYY again, 5880. Calculate that one. That's 0.0436 multiplied by 5880. And while I'm doing this, when I get my answers, I'm going to check that they make sense. So obviously, when I'm looking at correlation, I should be getting a solution somewhere between -1 and 1. So I'm checking that my answers lie between -1 and 1, which they do. So both of these are showing a positive correlation. So in part 2, it asks us to interpret and context each of the values that I obtained in part A. So obviously we can see that girth and weight are more correlated. So there's a very strong correlation between those two. So very strong positive correlation. And then for length and weight, but still positive correlation, but now it's a moderate positive correlation. And we need to make sure we're using the correct language here. So I've just seen here I've written correction instead of correlation. Sorry about that. So positive correlation. So we need to make sure that we know the limits of those correlations. So anything above 0.9 indicates a very strong positive correlation. and then anything between 0.3 and 0.7 is a moderate or some positive correlation. Okay. If we move on to part C of the question. So part C, we've got a bit of context there. So we're saying that measuring girth and length is a bit more straightforward than weighing pigs. So they've come up with a formula to estimate a pig's weight in kilograms from the girth and length. So we're given again some more summary data there. So now this is X is our formula. Calculate a third value of the product moment correlation coefficient stating which of G, L or X is most strongly correlated with Y. So exactly the same as what we've just done. So now we're using these new data, so I would need to do 5662.97, so that's the SXY, and we're dividing that by the square root of 565615. And we're still going to multiply that by SYY, which is our value that we had earlier on of 5880. So if I work that one out, I'm going to get a correlation coefficient of 0.982. So if I look back to my previous results and compare those, we can see that this is the most strong correlation. So it's the highest out of, for girth and weight we had 0.911, for length and weight we had 0.640. So X is most strongly correlated with the weight. So X is most strongly correlated with weight. So I haven't said what X is here, so I'm going to put that in here. The weight estimate. So just making sure I'm including the context of the question in my answer. Part 2. Estimate the weight of a pig that has a girth of 1.2 meters and a length of 1.15 meters. So now I'm just going to put that into my equation, my formula that I had up here for X. So the girth is 1.25, so that's what G is going to be. So X is equal to 69.3 times by 1.25 squared times by the length, which is 1.15. So I'll calculate that, and that would come to 124.52 kilograms. So I've just put in my unit there, so that's my estimate. Part 3, given the additional information that the mean X bar is 115.4 and Y bar, the mean of the weight, is 1.116.0, calculate the equation of the least squares regression line. So whenever I see calculate the equation of the least squares regression line, I'm going to go to my formula book and get my formula. So we can see here, because we've got the summary data, we need to use the formula. So first we need to work out what B is. So there's my equation I'll use to work out B. So this is part 3. B is equal to SXY. So that's 5662.97 divided by SXX, which is 56.15. So my value for B is going to be 1.00121. If I work out what A is then, so A equals Y bar minus B times X bar. So Y bar we said was 116 minus B times, so 1.00121 times by X bar, 115.4 work that out to get my value for A. So I've got 0.46085, so I've just calculated these earlier. So that means my least squares regression line, I can just put it in the form y equals a plus bx. So y is equal to a 0.46 plus 1.100 times by x. So this is really close to 1, we can see here. We can also see this value here of a is really quite close to 0.5. So if we go to question part 4, comment on the likely accuracy of the estimated weight found. Making reference to the value of the product moment correlation coefficient. So our product moment correlation coefficient was 0.982. This is a very strong positive correlation. So between weight and between the weight, the actual weight, and the estimated weight, that's what we're thinking about. So that's it. We think this is a very accurate estimator, okay? And this is also reflected in what values we got for A and B. So for A, we're saying the value of A was 0.5, and the value for B was 1. So the value of 1, that's saying the gradient is 1, the gradient of the line. So the estimated weight and the weight are very close. And A is really close to 0, so obviously if a pig weighs nothing, the estimate weight should be nothing. So we need to say here that B is close to 1 and A is close to 0, so it's approximately 0. Therefore, estimate highly likely to be accurate.